The following content has been provided by RWTH Aachen University.
So we'll see a short video about the technologies behind PARC's vision of the future. Maybe we can dim the lights one more time. Here we go. Oh, sorry, stole the audio here.
At PARC's Computer Science Laboratory, the ubiquitous computing revolution has begun.
All right, great. So this was the Ubicomp video, and again, done in, what did we say, 88, I think? 93. Oh, sorry, 93. There we go. Oh, yeah, the video, however, is a little later than the article. The article appeared in 91. That already sort of shaped the vision that he was talking about. So the first thing we saw here, devices, right? So these devices, what's unusual about it is that they already took this focus on the devices know where they are. Just knowing that a device is in a room can make a big difference, right? So your smartphone should probably notice that it's in this room right now and probably turn off the ringer. And when you leave this room, it should turn it back on. That's still not happening for a variety of reasons, but that's the kind of idea of awareness that the Ubicomp vision is having. Because this doesn't require any AI, right? Just this simple location information can be terribly powerful to adapt systems. And then the devices we saw were tabs, pads, and boards on an inch, foot, and yard scale, where there's hundreds per person, dozens per person, or one or two per room. For example, one of the stories that Weiser talks about is that every book should have in its spine one of those tabs, those tiny devices, so I can. So the first thing was the PARC Tab. They actually developed about 50 of these. This was, after all, a tech place. And it's the same PARC place, by the way, that had done the Alto and Star before, right? And these were kind of like active Post-it notes, you could say. We're able to animate objects, which means not animations on the screen, but it actually makes objects like a book interactive. It gives the possibility of a book knowing where it is, for example. But it's also used to vote, for example, in meetings via those buttons, used as an active badge to identify the wearer or the object it's attached to. You can shrink windows from a bigger screen onto the tab to take them with you. So the window is the important thing that gets transported, not the device. And as a research project, it assumed constant connectivity. This is an important trick that you often see in these visions. We just make an assumption, like a device can always be connected. And then they were able to, back in the late 80s, early 90s, to imagine interactions that this would enable. Now, of course, global coverage of LTE or whatever isn't even there today, and we still have moments where we're not connected because something's messed up with our smartphone. But these guys were able to think about what that would mean back then by just assuming that that's there, and then faking it by putting big fat tethers on their devices. Right? They would have a line going back with the LAN cable to be connected via Ethernet, but they would say, well, technically it could also be wireless. So what's today's tab? Does that exist? Yeah?
Yeah, it's our smartphone.
It's your smartphone. OK, so I can have your smartphone, attach it to a book, and you're fine? You don't really need it that much? Cheap enough?
I wouldn't say that.
Right, not quite, right? So you're right. Technically, a tab would be something like a smartphone. I mean, we saw even like handwriting recognition in there, sort of. You saw the stroke-based handwriting recognition, which actually made it into the Palm Pilot later on. As the graffiti input method, which was very en vogue for a while. But you also, and you also, I agree with the smartphone comparison, because did you notice that this thing was actually showing a screen of what you could probably call apps that you would tap on, and then the app would take the screen and show you information, and you could suspend it. It would never quite quit, and you could switch. So this was, it's iPhone.
But I wanted to add, they even implemented the home button.
Yeah, that was even the home button, right, the one that suspends the app, exactly. So on the one hand, you know, the technology of smartphones today fulfills a lot of these things. Always connected, yes, that's what smartphones are all about, right? On the other hand, the smartphone is an incredibly personal device, right? It's something that I don't give away. Whereas the tab is so cheap and disposable and affordable that it's actually not, the tab is not important. You know, you basically could attach it to something and it's fine. It doesn't need to be yours. While you get one and make it your active badge by, I don't know, logging in, identifying somehow, it's yours. But the moment somebody else takes it, it's his. So why can't I give my smartphone to you and you put your thumb on that button and tuk, all the data on there is yours. It's your phone now. You give it back to me, I put my thumb on there, it's my phone again. There's nothing that, you know, theoretically keeps us from doing that, except the devices aren't designed that way. Yes?
I would say the give it to me if you want. Because you can take the Chromebook from another person, log in with your Google account, and then you have all your data there.
Yeah, so that's a software concept, right? Yeah, but that's right. This idea of moving effortlessly getting your data onto some device without that being your own personal device for all time. That's an important step. Yeah.
Actually, I don't think that we should compare this stuff with the smartphone because actually, as it was said in the video, it's not a computer, it's just a client for using a real one.
Yeah.
So it's like a remote desktop in your pocket. So.
Yeah. So that was an important thing. They stressed that communication is more important than computation, right, on these devices. And again, we're trying to do a lot locally on the phone. But on the other hand, if you take things like Siri, you know, that's already using a web connection out to get the voice recognition be done on the server and then come back with the results. So we are beginning to see that kind of stuff happening, outsourcing things over an online connection. But communication is very important. So let's move on to the next part here, the PARC Pad. That's a kind of a crossover of a laptop with paper, they called it. It's a scrap computer. It's not something personal you carry around with you at all times. It just lies around like paper is lying around here in the room, right? So you come into a room, there's a pad lying there, you grab it, you do something with it, you put it back, you don't care about the device. It's not that valuable. It's sort of the antidote, the opposite of a Windows system, really. Because on a Windows system, we create a desktop that is whatever, 9 by 11 inches at the time. Now it's maybe a 30-inch screen. But still, the screen I have in front of me today is a lousy desktop, right? Even this table is like twice as big, right? And I know my table is even bigger, and it's messy. There's stuff all over it. So if I have to imagine that my computer is my desktop, then that's a really bad desktop. It's really, really small, and I have to stack things and put them away all the time. I can't use it as a large information landscape. So their vision is to say, well, don't try to put all your real desktop onto that virtual screen. Just imagine having lots and lots of screens that you can distribute in real space, right? If I want more display space, I just grab another pad, put it next to me, and then I've got 15 of those lying around. They're like stacks of paper, like printed articles or something. So when you compare this idea to iPad and modern tablets, what are things that are still missing? Why is an iPad not sort of the PARC Pad?
It is difficult to connect the iPad to a television or a system in which we can interact many people together.
Yeah, it's hard to have the system be part of this ecosystem, right? This larger interaction where I scribble on an interactive wall, and then there's a simple gesture that's to move the stuff down to my tablet, take it with me. And even me saying my tablet is kind of not the PARC idea, right? In that case, I would actually leave the pad on the table when I leave, and the data would still be in the cloud, we would say today, and I could get it onto another device very easily. So it's much more, if you look at it that way, a cloud-based idea than the idea of individual personalized devices. So the third one is the board, used as a video screen, but also as a bulletin board. And one idea in there was like, if it's a board with news, as I walk by it in the hallway, it will show information that I find relevant. It's a whiteboard, it's a flip chart. And this is one of the things that definitely needs also a different user interface. All these things needed user interfaces that were very different from the traditional desktop, obviously. For example, the keyboard is awkward, and you're standing in front of a whiteboard, you really want to scribble. You can't put a Mac desktop on a whiteboard, because I actually saw somebody do that when we ran a similar system at Stanford. She was jumping up to reach so the menu bar and the close buttons in the corner of the screen. So obviously a window-based GUI desktop doesn't make sense for a board that size. You just need a different GUI, just as you need a different GUI for a tablet and a phone, as we've learned. And this was something that was also supposed to be shared, internationally.
This content was provided by RWTH Aachen University.